Hey folks, so in this video we are going to be talking about electric field lines. And by the end of this video, you will be able to draw electric field lines for systems of up to 3 charges. So what is an electric field line, you might ask? An electric field line is a pictorial representation of both the strength and the sign of an electric field generated by a charge. So let's go ahead and look at an example. And what I'm going to do is I'm going to look at a single positive point charge, and I'm going to show you how field lines can depict both the strength of an electric field and the sign of the charge that is generating the field for this point charge. So let's go ahead and talk about strength first. So electric field lines are really just a series of lines going around our charge. So to show the strength of our field, I'm going to show that's going to be dependent on the number of lines, so the density of our lines. So let's say I start off with a medium electric field. So this is going to be the electric field for my first point charge. But what if I double the strength of that field? So I'll represent that by just drawing a 2 here. So when I double the strength of my field, I'm going to double the number of field lines. So I'm going to go ahead and add more field lines around my charge. And so you can see at any point around my charge, the field lines are twice as dense as they were before, demonstrating that my charge is stronger. So again, the strength of an electric field is depicted in field lines by the density of the lines. The other thing that you can see here is that our field gets weaker the farther away you get from the charge. So you can see here, our field lines are much denser than they are way out here. You can see that the distance between them is much greater in our outer circle than our inner circle. So what about the sign? So I can depict the sign of my charge, with the direction of my field lines. So for a positive point charge, for any positive charge, my field lines are going to be going out of the charge. So what I'll do is I'll draw arrows, as I am now, going away from my charge on all of my field lines. Now, you can choose to only draw one arrow. Oftentimes, there will be multiple arrows drawn on my field lines, just to show that they are continuously going away from the charge and to differentiate our field lines from vectors. So now let's talk about field lines for a negative charge. So again, we're going to start by drawing just the lines to show the strength of the charge. And since this is my single negative versus a double negative, I'm going to start with the same number of field lines I initially drew on my positive charge. And to show that this charge is negative, my field lines are going to be have arrows that are pointing into my charge instead of out of my charge. So again, if an arrow is pointing into a charge, that means that it is a negative charge. And if our field line is going out of our charge, then that means it is a positive. So now let's look at 2 positive charges. And I'm going to go ahead and start with the easy part here, which is the far side. So our field lines for our 2 positive charges together are still going to be going away from each other. So I can go ahead and I'll just draw a few field lines over here. But what about the middle? So remember that our positive charges are repelling each other. So our field lines are going to kind of look like this. So they're showing that the charges are repulsive, that our interaction is to move away from each other. So similarly, we could talk about a positive and a negative charge. So remember, our positive and negative charges are attractive. And in both situations, our field lines are going to go out of our positive charge and into our negative charge. So on this simple axis between them, I can just draw a straight line. And on the edges, so the top and the bottom, I'll go ahead and draw curved lines going out of my positive charge and into my negative charge. And I'll go ahead and I'll fill in the middle here with 2 more lines, again going out of the positive charge and into the negative charge. And then on the outside, I will have field lines going out of my positive charge and again into my negative charge, out of my positive charge, back into my negative charge, back out of my positive charge, and finally back into my negative charge. And so here we have a pictorial depiction of the field lines between 2 opposite charges. So now we get to the fun stuff, which is to look at systems of 3 charges. So we know that our field lines are going to go out of our positive charge and into both of our negative charges, like so. And then on the top and bottom, we're just going to have straight lines because it's not going to be pulled in one way or the other. And then again, we'll have lines going back into our negative charges from both sides. Okay, so some takeaways. So first of all, we can depict the sign on electric field lines using the direction of the arrows on our lines, because electric field lines will always go out of positive charges and into negative charges. Second, the density of the electric field lines shows how strong an electric field is. And finally, electric field lines are a useful way to predict how charges will interact. So when we have lines going out of one charge and into another, it suggests that that charge is going to be attracted, is going to be moved towards those other charges. And when you have a gap between those charges, like between your field lines, as we did with 2 positive charges, that suggests that those charges will repel from one another.